Now that we've talked about the terrestrial planets, we'll move on to the Jovian. So the Jovian planets are again also known as the outer planets. These are planets made of with a lot of gas, and they have very low densities. All of them are much larger than the Earth, both in diameter as well as in mass. As far as size, they range from 4 to 11 times the diameter of the Earth, and in mass, they go from 14 to 319 times the mass of the Earth. In other words, all of these are very, very large planets. They have much greater spacing between them than what we saw for the terrestrial planets. Starting from the closest of the Jovian and working out, we have Jupiter, Saturn, Uranus, and Neptune. So altogether, looking at all of the planets, starting from the closest to the Sun and working out, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Jupiter is the closest to the Sun of any of the Jovian planets. It is just beyond the asteroid belt. Between Mars and Jupiter, we have the asteroid belt. It is more than 11 times the Earth's diameter and is the largest of any of the planets in the entire solar system. Its mass is at 319 times the mass of the Earth. As we have studied it, we have found that its composition is actually more liquid than gas. The upper regions that we actually see are gaseous, but there should be a very large liquid component within the interior. We do expect that there should be some solid and liquid down towards the core. Here we have a nice view of Jupiter, and for me, anytime I think of Jupiter, I always think of the Great Red Spot. The Great Red Spot is a giant storm system in the upper atmosphere of Jupiter. By mass, Jupiter's atmosphere is 74% hydrogen, 24% helium, and 2% of methane, ammonia, and other things. Jupiter actually has a very similar composition to the Sun. It has no definite surface. We could not actually land on anything. Just below the cloud layers, we actually get to a liquid portion of the interior, although down at the very center, we do expect a solid core made up of rock and metal. But again, there's no chance of us actually reaching it. Don't try to land anything on Jupiter. It will just be destroyed. Jupiter has 4 of the largest moons in the solar system. Altogether, there are 7 large moons. We have the Earth's moon, then we have these 4 moons around Jupiter. The 4 of the moons closest, of the 4 moons, the one closest to Jupiter is the moon Io. Io is actually about the same size as our moon. However, it is very volcanically active. Io is actually the most volcanically active object in the entire solar system. Next out, we have the moon Europa. Europa has a similar composition to Io in that it has a lot of rock and metal. However, we do see that the surface is made of almost pure water ice, and that suggests there should be a region of liquid water ocean beneath this ice. This is very exciting because if there's liquid water, then we have the potential for life. The other 2 of the large moons are Ganymede and Callisto. So from Jupiter, we'll now move to Saturn. For me, whenever I think of Saturn, I actually think of the rings. If you've ever had an opportunity or do have an opportunity to look through a telescope and see the rings of Saturn, I encourage you to do it. They are spectacular. It's about twice as far from the Earth as Jupiter. Its diameter is about 10 times that of the Earth's, and its mass is about 95 times the mass of the Earth. So Jupiter is the really, really big one in the solar system, and then we get Saturn. Of all of the planets, Saturn actually has the lowest density. Its density is actually less than the density of water. What this means is if we had a giant cosmic swimming pool and we threw Saturn in, it would actually float. And, something that I find amusing, it has those rings which kind of look like a life preserver. So it's almost floating in water with its own life preserver. Now, the rings around Saturn we believe to have either come from bits of pieces around Saturn that never accreted and formed into a moon, or the remnants of a moon that was torn apart. Unfortunately, we don't know which of these is the case. Based on some evidence, it seems that the rings should be very young, within the last 40 or 50 million years. However, there is other evidence that suggests that they're actually ancient, several billion years old. So this means we don't really know what's going on with the rings. It's actually an ongoing question. As we look at the rings, we actually see that they orbit at different rates. The inner rings orbit faster than the ones farther out, similar to what we talked about with the planets orbiting around the sun. Ones closer in orbit faster than the ones that are farther out. The rings are made up of ice pebbles. Although I say pebbles, they do range in size from what you'd consider kind of a pebble all the way out to boulder size, closer to the size of a car. Saturn has one large moon, and this is Titan. It is comparable in size to Ganymede around Jupiter. Ganymede is actually just slightly larger than the planet Mercury. So Titan and Ganymede are actually both really large. In fact, depending on how you measure them, one or the other is actually the largest in the solar system. The reason why I say depending on how you measure. One weird thing about Titan is that it is the only moon to have a thick atmosphere, an atmosphere comparable to the Earth's. And so if you include the atmosphere as well, then Titan is actually larger than Ganymede. If you do not include the atmosphere, then Ganymede is the largest. Titan is far enough away from the sun and has the right atmospheric pressure that methane can be a solid liquid or gas, similar to water on the Earth. What this means is there's actually a hydrologic cycle, or at least we believe there's a hydrologic cycle on Titan. So we have methane evaporation leading to methane clouds and methane rain, which leads to methane rivers flowing out into methane seas, which is really exciting. And so we see a hydrologic cycle, but not with water. Another kind of fun thing about Titan, because its atmosphere is actually slightly thicker than the Earth's. It's about 1.5 times the thickness of the Earth's atmosphere. But it is very small, being comparable in size to Mercury. Because of that, it has a much lower surface gravity than the Earth does. What these two things together means, with a higher atmospheric thickness and less gravity pulling down on you, if you built yourself wings like a bird, you could actually fly under your own power on Titan. You could fly like a bird, which is awesome. Continuing out, we have Uranus. Uranus is twice as far from the Earth as Saturn. Its diameter is about 4 times that of the Earth's. One really strange feature of Uranus is that it's actually tipped over on its side. It has an axial tilt of 98 degrees. The Earth is also tipped, but it's only about 23.5 degrees. What this means is that Uranus actually rotates in like this as it goes around the sun like this. It's really weird. So on the summer solstice, the longest day of the year for the hemisphere, the pole is almost pointing at the sun. It does have a faint ring system. In fact, all of the Jovian planets do have rings. Saturn's are just the ones that are easily noticeable. In fact, we didn't discover Jupiter's rings until we started sending spacecraft to it. We don't really see them from the Earth. The atmosphere of Uranus is predominantly made of hydrogen and helium, although there is about 2% of methane. The methane is actually what gives Uranus, and we're going to see in a second, Neptune, its kind of bluish color. Methane absorbs longer wavelengths and reflects short wavelengths, so the blues, greens, and purples are reflected stronger. It is also a very, very cold place because we're getting very distant from the sun now. Neptune is the last of the planets of the solar system. It is the one that is the farthest from the sun. Its diameter is also about 4 times that of the Earth, although it is slightly smaller than Uranus. Its atmosphere is again predominantly hydrogen and helium, with about 3% methane, which is again what gives it its kind of bluish color. Now, although Pluto is not considered a classical planet, we're going to talk about it at least a little bit. So for a long time, Pluto was actually considered a planet. It was first discovered in 1930 by the astronomer Clyde Tombaugh. And since that time, until 2006, it was considered a planet. The reason why definition was changed is actually because we started to find other objects that were similar to Pluto, and based on how many there were and how often we were finding them, it seemed that there were possibly literally thousands of objects similar to Pluto. And if Pluto's a planet, these thousands of objects must also be planets. And yet they are very, very different from the other planets, the terrestrial and the Jovian. They're very small in size, they have strange orbits around the sun, they're not made of the same things. So, because of all of this, there was a vote held by the International Astronomical Union, which is the kind of governing body that determines definitions and other things, and it was decided that we needed to have a new category for Pluto and all of these other objects similar to Pluto that we were finding. So the term that was defined is dwarf planet. To date, there are 5 accepted dwarf planets. There is Ceres, which is located in the asteroid belt. Then, out in the region beyond Neptune, there is Pluto, Haumea, Makemake, and Eris. And Makemake is super fun to say. Because of who I am, my kids have a favorite dwarf planet. Their favorite dwarf planet is Makemake, simply because it is super fun to say.